Hello, my name is Sebastian and welcome to the short presentation of my poster on usability testing of a multi-level modeling framework for just-in-time adaptive interventions in mobile health. Let me start by explaining just-in-time adaptive interventions. The just-in-time adaptive intervention is an intervention designed for a digital health intervention to support health behavior change, for example, to promote physical activity. The just-in-time adaptive intervention combines real-time data and knowledge about an individual and its context, for example, the weather, to provide personalized interventions using artificial intelligence. For example, while waiting for a bus, a just-in-time adaptive intervention may suggest to do some exercises, such as air squats, or walking to the next bus station if the weather is nice. And if we want to compare data across studies or analyze data across studies, we will have to perform data integration since data is stored according to different data schemas with different configurations and so forth. And therefore we designed a framework that combines conceptual multi-level modeling, composition hierarchies, and specialization hierarchies in order to eliminate the need for data integration. However, we also pointed out the complexity of the framework and the size of models created with the framework. And therefore, the aim of this study was to investigate the usability of the framework. We developed a proof of concept prototype based on JavaFX and standardized semantic web technologies such as RDF, Sparkle, and Shackle. And the proof of concept prototype does not hide the complexity of the framework and the size of models, but it provides means to work and navigate with or through models. Here on the right hand side you can see a screenshot of the prototype. It's very Windows Explorer-like. So here on the top you have a text field in which you can search for elements with their names. On the left-hand side, you have a tree view in which you can navigate through the hierarchy of a model and select model elements. In the center, there is a description of the currently selected model element with links to connected model elements. And on the bottom, there is a text field in which or text area in which the currently selected model element can be edited. And also there are two buttons, for example, the add button and delete button, in which model elements can be added to the model or deleted from the model. And the prototype also provides means for querying models and so on. So in order to investigate the usability, we conducted two usability tests with students of a lecture course on semantic artificial intelligence. In the first usability test, we only provided them with a multi-level modeling tutorial and a basic version of the proof of concept prototype. And then they were asked to complete 8 tasks within a week. So we basically reduced complexity in the first usability test by removing or simplifying the example so that they only have to deal with one level of composition hierarchy, so they can focus on getting used to multi-level modeling. We removed, for example, the add and delete button since this was not necessary in the first usability test. And you can find the tasks of the first usability test by scanning this QR code. And we also provide the summary on how successful the students were in solving each task. In the second usability test now, we provided them with a presentation on the framework and the proof of concept prototype. And then they were asked to complete 10 tasks within 60 minutes. And you can also find the tasks and the summary of each task here by scanning this QR code. After each usability test, we invited the students to complete a survey in which we asked the items of the usability metric for user experience, the items of the raw NASA task load index. And we also ask them to provide their solutions so we can assess how many tasks they completed successfully, how many they did not complete, and how many they did not even attempt. And just a reminder that the first usability test was served only as a preparation for the second usability test, so you cannot compare them at all. And even though we provided them with a preparation for the second usability test, they face difficulties. As you can see here, they only completed 56.4% of the tasks and did not complete 27.3% and did not even attempt 16.4% of the tasks. And this may be due to the inherent complexity of the framework, which means the complexity of combining multi-level modeling, specialization hierarchies, and composition hierarchies. It may also be due to the accidental complexity of the front end. For example, for adding a model element, you have to prior select the appropriate model element, or you have to select the modeled model element in order to remove the childs of the model element. And inadequate instructions on the proof of concept prototype, maybe they would have needed more time or more explanation on how the proof of concept prototype works, and or lack of understanding of the framework. So maybe they would have needed more time and preparation for working with the front end. And therefore we will work on hiding the complexity of the framework and improving the front end and the instructions, for example, by developing guidelines. So thank you for listening to my presentation. If you want to reach me out, you can find my email down here. And I wish you a nice day. Thank you.